This is our second video discussing bearing. In this video, we'll discuss our second method. Expressing bearing starts with either a north or a south line and uses an acute angle to show the direction, either east or west, from this line. Either north or south always comes first, followed by an acute angle, and then east or west. I actually prefer this bearing method. So we'd have something like north 15 degrees to the west. So that means start with a due north line and then rotate 15 degrees towards the west, right, using our cardinal directions. It'd be right here. The bearing from Atlanta to Macon is south 27 degrees east, and the bearing from Macon to Augusta is north 63 degrees east. An automobile traveling at 60 miles per hour needs 1¼ hours to go from Atlanta to Macon and 1¾ hours to go from Macon to Augusta. Find the distance from Atlanta to Augusta. We'll round to the nearest hundredth. As always, we want to start with a good diagram. It says that the bearing from Atlanta to Macon is south 27 degrees east. So we'll start here at Atlanta. Its bearing is south 27 degrees east. So we're going to start with a due south line and then rotate 27 degrees towards the east, which would be, sweeping to the right. And that gets us to Macon. And the bearing from Macon to Augusta is north 63 degrees east. So they're giving us a new bearing. We're going to start with a due north line this time. And then we're rotating 63 degrees to the east. And that gets us to Augusta. Okay, so there's our bearings. We got an automobile traveling at 60 miles an hour, needs 1¼ hour to go from Atlanta to Macon. So that'll give us the distance in between. Distance is equal to rate times time. So 60 miles an hour times 1.25 is going to give us a distance of 75 miles. And then that same vehicle going from Macon to Augusta needs 1¾ hours, so 60 times 1.75 is going to give us a distance of 105 miles. And we want to find the distance from Atlanta to Augusta. Now we can see our triangle. We're trying to find this distance x. We know the other two sides of the triangle, so if we could prove that this was a right triangle, then we could just use Pythagorean theorem. So we want to think about how we can prove that this is a right triangle. And it looks like this would be the angle. That would be the right angle. And I already have some information. I know that a portion of that angle is 63. So this is where I'm going to focus my attention. We have a due south line and a due north line. Well, those are parallel lines. And we have a transversal here cutting those two parallel lines. We know that alternate interior angles are congruent. So that means that this other half of that angle is going to be 27 degrees. I'm sure you're noticing we use this technique a lot, especially in bearing problems. Now, looking at this angle, 27 degrees plus 63 degrees, that does give us 90. So I'm going to draw a breakout triangle for us. I think I'm going to turn on its side too. So this is 75, this is 105. We're looking for x. That's the hypotenuse of our right triangle. X squared is going to be equal to 75 squared plus 105 squared. And I just put a square root over top of this and put it all in my calculator at once. We're rounding to the nearest hundredth. X is equal to 129.03, and our unit is miles. Let's try another one. Radio direction finders are set up at 2 points. We'll call them A and B, which are 2.50 miles apart on an east-west line. From A, it's found that the bearing of a signal is north 36 degrees 20 minutes east, while from B, the bearing of the same signal is north 53 degrees 40 minutes west. We want to find the distance of the transmitter from point B. We'll round our answer to the nearest hundredth. As always, we're going to start with a diagram. We've got these radio direction finders, A and B. They're set up 2.5 miles apart on an east-west line. So here's our east-west line. Our A and B, with a distance of 2.50 miles in between. All right, so there's a signal out here somewhere, but they give us bearings. So from point A, the signal is north 36 degrees 20 minutes east. So we're going to start with a due north line. And then rotate 36 degrees 20 minutes to the east, which is going to be to the right. And then from B, the bearing to that same signal is north 53 degrees 40 minutes west. So we'll start with another due north line off of B. And then go 53 degrees 40 minutes to the left, which would be our west. And this should be where this signal is. They want us to find the distance of this transmitter from our point B. So we're looking for this blue side. Well, here's our triangle. I don't know much about it. I only know that the one side is 2.50 and I'm looking for the other side X. I don't have any angles inside at this point, and I certainly don't know that it's a right triangle. So we need to start by getting some information inside our triangle about the angles. Points A and B sit on an east-west line. We have at point A a due north line. So that due north is going to make a right angle with the east-west line. And then the same thing's happening over here at point B as well. So we can find these angles inside the triangle because they're going to be complementary with the two that we have outside the triangle. So our angle here on the inside doing 90 degrees minus 36 degrees 20 minutes, we get 53 degrees 40 minutes. And then doing the same thing with the other interior angle over here, 90 minus 53 degrees 40 minutes, we get 36 degrees 20 minutes. And then to get our last angle up here, we'll do 180 minus those two angles. And when we do that, we get 90. So we do indeed have a right triangle. I'm going to draw a breakout. We know this is 2.50. This is our right angle. This is X. And really we only need one of the angles. I'm going to choose this one here. From our angle 53 degrees 40 minutes, our side X is opposite. And the 2.5, well, that's our hypotenuse because it's directly across from our right angle. So opposite and hypotenuse, that's going to be sine. So sine of 53 degrees 40 minutes is equal to X over 2.50. And to solve for X, we'll multiply both sides by 2.50. X equals 2.50 times sine of 53 degrees 40 minutes into our calculator, and we're going to round to the nearest hundredth. We get X to be 2.01, and our unit is miles. If you had chosen to use the angle over here, 36 degrees 20 minutes, you would have just had to use cosine as your function instead, because relative to that 36 degrees 20 minutes, X is your adjacent side, and 2.50 is still your hypotenuse. So you could do it that way, but you would have ended up using cosine.